Hello, good evening all. Welcome to overview of CAE Industry. Myself Tara, I work for Decibels as a senior FEA engineer. With me, Vinayak is there and the Surasar is there. Surasar is also there. Let's start the session. Welcome to the overview of CAE Industry. As in continuation with our the last sessions and the last sessions of the CAE industry topics, in continuation with in this session, I'm going to discuss about overview of the CAE industry. Overview in the sense we can like before coming to the CAE industry, what it is, what is the work nature, why the CAE industry is required, like why the CAE industry is required and all. We will discuss in this webinar. As we all know, the CAE industry has occupied all over the all in all the automotive parts, like automobiles, defense, electronics, and medical devices, even the industrial equipments and others so on. As we all know, the CAE is not only meant for the automotive sectors, like it is in the aerospace also, it is in the medical field also, and electronic side. Say for example, LED televisions, or mobiles, or even the domestic purpose usage items also, the CAE industry is occupied. And heavy trucks, as we all know, it is very important for the aeronautical purpose, for the aerospace work and all. The CAE industry is occupied all over the things. And this is the CAE industry market. As by North America has given this graph, we can observe from 2018 to 2028, they have given some graph. In that, you can observe it. What is the CAE? Like it is growing every year. It is growing. According to this market, the CAE growth is there. And here, in the current CAE market, they are moving for the, like earlier. What they are going to they are deploying the software at the customer end. Say for example, I'm taking some CAE software, means they are coming to our side and deploying the software. But now they are moving for the cloud. Here, in the right image, we can observe it. Now, cloud is also occupying. What is the cloud, or what is on the on-premises? It means, say somebody is having the CAE software, and we are purchasing, or we are going to use it, means they are coming to our place and deploying the software. But now cloud is occupying. Why? Means it is easy to access, it's a less space for data storage and all, and it is a scalability purpose. Compared to on-premises, cloud will work faster and enables the distribution and minimal maintenance. So now the CAE software is also moving for the cloud, but compared to cloud and on-premises is occupied more majorly because of the data security purpose. If it is in the on-premises only, all the data will be with the customer side only, or with the company side only. But what if the cloud means it is the storage, somewhere else it is going to store the data. But compared to cloud and the on-premises is occupied. Why? Because of the data security purpose. Next is, what are the benefits of the CAE? Since we are discussing about like the CAE and all, we should know what are the benefits. We can in practical sense, if we are talking about, means if you are buying something, any software, means first we will go with the what are the benefits of this, what are the benefits of the software. Now, as I said, CAE is occupying all over. Like we should know what are the benefits, why it is occupying all over, like including the mobiles, medical field, or complete automotive field. Means these are the main reasons why they are shifting to CAE. Prototype testing, efficiency, and optimized designs. We will discuss one by one in each slide. First, we will come to the prototype testing. What is prototype testing? How it will interrelate to the CAE? Next is efficiency. Like using the CAE, how the efficiency of our work can improve. And what are the optimized designs? See, here you can observe in this image, like it is an air wing. Bending test is, they are doing bending testing here. I'm telling the prototype, the main reason of CA is the prototype testing. It means when we are doing any practical test means we need one model. We need one model, but it requires more time to build it. First, the designer has to design it. Then if the designer is done with the product, then it will come for the production. After the production, it will move for any of the practical test. Say they have built one air wing. It will take so much time to build just to build this one air wing. After the building, practical tests like as we are doing in CAE, any stress test, doing any stress values, strain values, it deflections or deformations, so on. Everything, it will take so much time to do manually. Whereas in CAE, it doesn't require any physical models. We will just go with the model which is designed. Then we will apply the practical things using the CAE software. This is one of the major advantage using the CAE. Just assume somewhere the air wing is not coming to my value, or it is not meeting expectations of that material or the stress values or any deformations. Again we need to redesign it, and we have to do manufacturing, and again it will come for the prototype testing or the physical testing. But what if it is for second time is okay, next consecutive terms means it will cost more, like the cost of the production will increase, and it will require more manpower also, and moreover it consumes so much time. So to come over all this, the CAE has introduced. In this CAE, we can do any iteration to the nth iteration we can do with the minimal usage. We are not producing it, we are not manufacturing it, we are not doing any physical test, but our software will do everything. After the CAE results, we will take up for the physical test. But while doing the physical test also, we are not considering the values in only the one test. It may be 2-3 times they are doing prototype testing or physical testing. This is a main advantage of CAE. So here the prototype is not required. Only we are all our work we are doing using the softwares only. After the software results only, then it will go for the manufacture, then it will go for the physical test. Next is efficiency. As I said, the prototype is not required means obviously the efficiency will increase. So I can do nth iteration, I can do any infinite times of iterations. One in the first iteration I may get nearly 80% of the value, the next might be 80 to 83, like that. So I can do any iterations. Then after all the iteration, I'm coming to the one value, or I'm coming to the one design of the component, and I can go with the manufacturing. Then I will go with the manufacturing of that. Obviously the efficiency will increase. Next is the optimized design. What is optimized design means, when we are doing when we are designing any component means, we will not be knowing whether it is the component, whether the structure is completely required or not, that we will not be knowing. But using the CAE software, it will tell us, okay, optimized design means it will give some range of value, which will give some set of values. With that set of values, we can design any of the component. That optimized means it will not show less amount of design or less amount of material usage, or even that for preparation of that material component also, that will not give. It will give an optimized solution for the particular component what we are going to design. See, we can improve the efficiency means, see here in this slide, I can clearly say that, see, this is a process before we introduce CAE First, the designer will design the CAD. Next, the virtual test. It means any physical test. If it is after it will come for the build, then it will be tested. if the test is not passing means again it will come for the redesign. But whereas in CAE, first will come to the conceptual design, then using any of the design software, we are going to design that CAD or we are going to design any particular component. Then the virtual test, in that virtual test, in the CAE test only, we will fine tune it. It means here, say for example, I'm doing 10 iterations. Out of 10 iterations, I will get a different 10 values. It means out of 10 value, I can go best of it. Say for example, in first iteration, I'm getting the deflection about 1, 2, 3 like that. But consecutive out of 10, if I'm getting 5 or 6 or something like that, means in between 5 to 6, I can go with that. If that value is fine, I can go with the manufacturing that component. If that value is not fine, or if the design is not meeting my expectation, means again I tell to my designer to redesign it, to redesign the CAD of that component. Next, if the designing is done, then again it will come for CAE. If all the CAE tests are done, then it will move to the production or manufacturing that component. As usual, after manufacturing it, it will come for the physical test. So by doing this, while coming to the end of the test, while doing physical test, I may do two or three times only, but not more than that. So it will save my money and time, manpower. So all these are beneficial by the CAE software. So this is the main purpose why the people are using the CAE. Next comes to what are the roles of a CAE engineer? As you all know, once we are entered into any of the streamlines, there will be a set of roles for any of the work. See, these are the points which I have noted on for role of a CAE engineer: planning, product design, simulation, optimization, and flows planning. Planning means as soon as we assign by any of the work, we should plan in such a way that the work like assigned work should get complete within that hours only, or the work you are going to deliver, it should be within the timeline only. So the CAE engineer has to think it in such a way that he should not end up with a more time, or within the certain defined time only, his work should be 100% correct. Like say, for example, you are assigned by 5 hours of work means, say for example, 1 day work if you are assigned means that 1 day work should be completed within a certain defined timeline only. It should not be more than that. So the CAE engineer has to plan according to that. Next comes to the product design. While modeling any of the things, you should be aware of that how it should get modeled. Like there is a set of procedures for each of the models to design it. Next comes to the simulation or analysis. So after the planning and all, we need to analyze the component. After analysis, optimization. Optimization means we should tell to the customers, or we should analyze in such a way that whether the required material is enough, or it is a over material, or it has a less does it require a less material, and we should analyze it. It is the optimization. If it is over designed or if it is a less designed. Say for example, consider any of the one chair which is having the 4 corners. Just assume out of the 4, what if it is having only the 3 legs? So you have to analyze in such a way that it requires the 4th one also, because to withstand the weight. So if it is in 3 leg means it may not be carry all the way to it will not distribute all the way to the overall complete chair. But if it is having the 4 legs means it will be good. Then it will distribute the equal amount of load to all the area of the chair. So it is called optimization. Or sometimes what happen, the component may be over designed, or the component may not require that material properties. So in this way, whether it may be a size optimization or shape optimization, like that. Next is the post planning. What is post planning means? After we got some result, we have to deliver that results in such a way that where are the stress regions, or what is the deflection values, or what is the deformation shape of the component. So all the things it will come in the post planning things. Next is, see, this is the role of an CAE engineer, but what is the work he is going to do in any of the industry? See, first comes to the meshing part. As we all know, for the CAE, first thing is the meshing one. And like you will be assigned some component, and they will be given you the set of instructions how to follow or how to build that model. So using that guidelines or using the data, we are going to mesh it. Meshing only consumes so much time compared to all this. Say for example, if you are doing one automotive door component, to that automotive door component, for 100% of its work, the meshing only consumes more than 50% of its work. Or I can say more than 60% also sometimes. It depends on the complexity of the component. So meshing only will consume most of the 100% work. Nearly 60% it will consume. So all our major work will be on the meshing side only. So before starting meshing and all, as we discussed in our earlier sessions also, what are the meshing guidelines that will be given by you according to the component one, and how to carry out the meshing. After meshing, what are the things to be taken care before delivering the meshing? So all the things to be taken care while doing meshing only. To do all these things, we need elements. So elements can be created by nodes. So elements on the nodes will be done in the meshing side only. So meshing is the main role. Any of the CAE, meshing is the main task, like giving a boundary condition or solution results, or accepts all this. Meshing will take more time, and it is a process wise. Like see, for example, I'm doing the meshing for this rail component, means directly I can't go like here or there. I can't start the meshing. There is a guidelines to start the meshing, or there is a set of procedures to follow for the each component, or for the each feature of this complete assembly. See, for this is called a complete assembly of this. There is a set of things to be taken care. Next comes to the boundary condition. It means after doing some meshing and all, we need to give some boundary conditions. It's like where you are going to fix the component, or where you are going to mount it. So those things comes under boundary condition. Next is the finite element method of finite element analysis. Like what type of simulation we are going, what we are going to do, any crash analysis, any durability analysis, or something like that. Next comes to the solution part. See, I have decided some analysis. I'm decided to do some durability analysis using an OptiStruct solver. Then I will go for the solutions. After the solution, see, I have done some meshing and have given some boundary condition, loads, etc. things. Then comes to the result part. What it is in the result means, I have given something for the software, and it has given written back to me in something in the HTTP format or any results file. So I need to review the results, whether the applied conditions, boundary conditions, whether it may be, or the material properties. Or any of the material properties of that. So whether it is a correct or not, that we are going to validate in the results part. It will comes in the validations. After we got some results, we are going to plot it in using any of the results viewer. Say for example, Hyperview. Hyperview is one of the all-type product for visualizing or validating the results. Say for example, for this component, I'm getting some stress value at the corner of this component. So by viewing any of the results file, I may not come to know whether the results is applicable for the certain 10 elements or 20 elements like that. So visually, I want to view the results. So I'm validating the results using some softwares. So like before validating, some idea I should be there. Okay, if the stress is coming in any of the critical section, or any of the where the stresses are coming, so I need to validate those data. After validating, if the validated results are correct means, then I will go for reporting the data. So reporting means I'm just going to tell, okay, here the stresses are coming, or here the deformations are more, or the deflections are more here. Just I'm going to report it if it is a validated results. So this is the procedures. So all the CAE industries following the same procedures: meshing, boundary condition, solution, results, and validating the results and reporting the results. So this is only the things that all the CAE industries following. Next comes to the what are the job roles for the CAE industry. See, since we are talking only this overview of the CAE industry and what is the work of the CAE, what is the work of the CAE engineer or an analyst like that. So next comes to the like of what is the what are the entry level job roles. Like it all depends on the company wise, like industry wise only. It is not some industry may call it as a FE modeler or a machine engineer, and some may call it as a design or application engineer. So as I said, it is all depends on the industry perspectives. See, some may call it as a product design. See, some of the, say for example, you are working in any of the one service provider means they may call it as, they may call you as a FEA modeler, a CAE engineer, a design engineer, application engineer like that. But when you are working with any of the product based company, they may call you as a product design engineer or project engineer. So these are the job designations or the job role names that the CAE industry is following. Next, what the industry is expecting from the CAE person. See, as we discussed, machine part and what are the job roles we have discussed, and why the CAE industry is required. So those all are we have discussed. Now next comes to the what is the industry is expecting from any of the CAE engineer. See, once you are get placed to the any of the company, that the industry is also expecting something from an analyst or something from an engineer. So the CAE engineer has to perform the complex design analysis using any of the CAE software. Like as we already know, as many of the CAE software comes under Hypermesh. It is one of the Altair product, and OptiStruct or Radius like that. Then understand the customer basic requirements and expectation for the new product design and improve the designs. It means daily you are assigned by some hood assembly like that. Say for example, I'm telling you are assigned by some wood assembly means you should understand the requirement of that components or requirement of that particular simulation, whether it is go for any crash. You should think like, okay, if I'm doing any hood means it may be a crash, or whether it may be of a durability or any of the simulation it is. And requirements of that analysis. Requirements means for meshing side also it may be, or giving the boundary conditions also, or any of the load perspectives also. So you should understand the requirements of the new requirements of that particular simulation or analysis. And if it is required any design changes or improved designs, design product design and improved design. There is a difference between new design and improved design. So in CAE industry, we are all going with the improved designs only. First, we will think of improved designs. It means you just assume any bike fenders are there, that the front part of front wheel, on top of the wheel there is one sheet metal component is there, that we call it as a fender. Just assume that fender is already there. I have measured that component and I'm analyzing that component. But if the stresses are coming in any of the area means I'm not going with the new design of the component. I'm just going with the upgrading the design, or I'm going to improve the design of that. I will go with only new design if it is a new product. But I'm doing, but like iterative purpose I'm doing means I will go with the improved designs only. We have to suggest for the improved designs, how, like by changing any smaller area of the design, or by adding or removing any of the geometrical sections. Say for example, by adding any ribs or changing the fillet radius, something like that. We should suggest it, or we should improve the designs. Next is the next industry is expecting means we should be minimal supervision, because all the CAE engineers are running with the like timelines or time frame, within the time frame only. So nobody is there to like come and help you, like okay, by teaching you that, no, they will not do like that. So or the industry is expecting is with a minimum supervision by understanding the requirement, or you should be capable of doing any of the complex geometries like that. So you should be a you should be in understanding such a way that you should be a quick learner, I can say. Next is the meshing experience in meshing software. So for CAE, the meshing is the main part. So you should be knowing what is meshing, using the softwares, how to do the meshing, like after the meshing, what are the things to be carried out. So those things should be aware of that. Maintain the record of all the activities and results in the CAE project database. Once you're done with any of the work or any of the project, those things to be recorded. Why? Because as I said, CAE will come for the improved designs only. Improve daily, we are upgrading the designs. So we are for in freshers or in for entry level engineer. If I am telling means he will not work under the any of the new design product. He will work with the improved design products only. So maintaining the old records will be a major advantage for the fresher or a new person new to the industry. So these are the main points the industry is expecting for any of the CAE engineer. Next is, see, we have discussed CAE part and what the industry is expecting. Next, what is the tool chain used to learn any of the CAE softwares? Altair is there. As we already know, Hypermesh is one of the toppest meshing software everybody is like majorly that Hypermesh is one of the major tool that is using worldwide for the meshing purpose. It is a top one software. Next comes to the ANSYS is also there, Autodesk is there, Siemens is there. So these are the many other toolchain softwares that we can learn the CAE. Next comes to the what are the career opportunity or where the CAE is going to implement, like which are the companies they are using the CAE softwares. Here I have kept only the few companies. There are more companies which are using CAE than these companies. TCS is there, Mercedes is there, Klein, HCL. So these are the many other companies they are using CAE softwares for any of the simulations or any of the test crash analysis or any durability analysis like that. Next is, okay, till now we have discussed the overview of the CAE industry, like what is the CAE industry, next to the where they have implemented the CAE, like why we have to go with the CAE industry and what is the industry is expecting from any of the CAE engineer, and the job roles or job roles for the industry, and any of the job role for CAE industry who is working in the part of any projects. So we have learned till now. We have discussed till now. In the next part, in decibels, let's consider the decibels part. In decibels, we are providing one master course certification for the automotive CAE, master certification course in automotive CAE. You can join this course so that you like all the things what I have discussed till now. So you can learn all this in master course. The Decibels is offering the master course CAE, automotive CAE. And in this master course, what and all comes under means it is a 9-month course, nine months course. There we are going to build these projects. Starting from the minor projects to the capstone project or any of the assembly level also, we are going to learn in this master course. And we are already started one master course, and the master course batch is going on. And if you want to opt for any of the master course batches and all, you can contact the Decibels. So I can say like CAE is a vast, like you can get opportunities. Like if you know any of the CAE softwares and if you are certified by any of the CAE software means you will get placed very early in any of the CAE industries. So this is an overview of the CAE industry, and thank you.
Thank you, Tara. Thank you for the session.
Yeah.
Thank you guys for joining in, and I have shared the link for the master course if you like to go through it, and I'll be sharing the link for the generating your certificates in the chat box. You can generate your certificates there as well. I'll just show you how to generate your certificates. Tara, can you stop
Yeah,
the.
yeah, yeah. I have stopped.
Yeah. Is it visible, Tara?
Yeah, it's visible now.
As I've shared a link in the chat box, you have to just click it. You'll be landing here. Just tap it on enroll for free. Then you'll have to type it on the Google or whichever the if you are logged in from the LinkedIn or if you're logged in from the Google, you just have to use those Gmail for logging in. It should be registered with the our website. There's some content which you have to go through. Just skip it. There is a small questionnaire here. Please answer all those questions. Just typing out here. Completed it. Continue. And then you have to click on complete and then tap it on get your certificate and your certificate will be generated. You can share, you can download and keep it safely with your, and then you can copy paste the link. You can share it on Twitter, Facebook, LinkedIn. If you share your certificates in any of the social media, please do tag us so that we can reshare it. Thank you guys. Just a second. I'll be sharing a feedback form. Please fill it. Just give me a minute. I've shared you the Google form as well. Please do fill it. It help us to improve our topics or anything related to the sessions. Thank you to the guys who are watching from YouTube.